All right, this video is to demonstrate the in-class portion of activity 1.2.5. Trying to keep my engineering classes straight. I think you're both on activity 1.2.5 to record the demo. I just recorded a Fusion demo earlier. So for the 555 clock timer circuit in Multisim, and this is what we will be doing in class together. But if you're absent from class and you need to see the demo in order to construct your own, or we just moved a little bit too fast and you need to be able to go back and like rebuild it, that's so that's what this video is for. So hopefully I can do it without too much ado. So we have our blank document there, and I actually haven't used Multisim in a little bit. I've been doing a lot more in Fusion recently. So we have our VCC. I'm going to construct this circuit exactly as it is in the PLTW curriculum. So I'm going to put my power here and my ground. We'll give myself plenty of space to work with. Then we need some stuff. We need 3 resistors, 2 capacitors, an LED, and the clock timer. So let's go grab those resistors. I need 2 330 ohm resistors. So we'll just plug in 330. And we need 2 of those. They both go over on this side. So we'll just plug a couple of those there. We need a 180 ohm resistor, and that is more over on this side. We just had a faculty meeting, so there's a lot of text messaging going on. Sorry about that. You can hear my phone. All right, we need 2 capacitors. We need a 22 microfarad capacitor, and that is about here. And then I believe, I hope I wrote this down right. I wrote 0.01 microfarads, which is there. Okay, so, and that's about here. All right, let's go find our, I think LEDs are under indicators, but maybe not. Hex display. No, we don't want a probe. We need an actual LED. Let's LED. There we go. Ooh, what color? We can pick a color. Let's do. We'll do a red one. No, I don't want. I want something that looks like that. I don't know what that was about. That looked more like a Tinkercad one. We'll just do a blue LED. Okay, and the blue LED is somewhere over here near the 180 ohm, and then we need the actual clock timer, and that's an LM555 CN clock timer. There it is. It's beautiful, and that goes right about here. All right, I think that is all the components that we need. So we are done. We're going to close that out. And now we need to get all the wiring in place. I might need to move my components around a little bit. It's all good. So let's connect this to VCC. Now, if you're interested in what all these individual pins are, then you can go back and look at that presentation in the PLTW curriculum. There's kind of like a very lengthy presentation on it. All right, let's go. I'm going to turn this. So I'm going to hit Control R and kind of turn that. And that does not need to be quite as far away from there as I had it. I gave myself a little bit too much space there. Let's connect this, and then this RST kind of connects in here. So then we connect the 2 resistors together, and in between them is the, there we go, is the DIS pin there. And then we need to rotate this capacitor. We actually need to rotate them both. Let's go ahead and do that. And we can move this in line here. Okay, and this resistor does connect to this capacitor, but in between we have both of these pins connected. Now, see how that's kind of running over my label there? I'm going to kind of redirect that myself just so it's not in the way there. And okay, so both of those pins are connected. Then this pin comes to this capacitor, and these two capacitors can be connected like so. And then we have ground, and oh, I'm going to have to place a joint. Great. Or a junction. We'll place a junction right here. Okay, so that I can run. Oh, why is it doing that? I don't know. Fine. Also not what I intended to do. There we go. Okay, I think that's all connected. Zoom in, make sure that's all connected. Not the neatest job I've ever done. All right, and what else do we have happening over here? We can move these guys a little bit closer, and we can rotate this resistor. All right, this resistor needs to run over to the ground. There we go, and we'll connect that up here. And then this is connected to the output. All right, now in order to monitor this, we are going to need a 4-channel oscilloscope. So I'll come over here. We want that 4-channel oscilloscope, and we're going to hook channel A up to the output there. All right. So that doesn't take too long. Hopefully you're getting more comfortable with building that and reading the schematics. Sometimes it's interesting to think, about a month ago, where you would be at with using the program and simulating the circuits versus where you are now. And hopefully that is getting much faster. Now, once we build that, now we need to record the frequency and the duty cycle of this particular clock timer. So I'm going to go ahead and start the simulation, and we can see our LED is shining. I guess that's, it's shining. And we'll double click on the scope to see it. And then we need to pause the simulation, and we just need to pause the simulation, hopefully at a time where we can see enough of the, okay, that should work. Okay, so we're looking for the frequency and the duty cycle. What I'm going to do with this is we're going to use the little bars, the T1 and T2, and we'll use the T1 and T2 to get the time high, and we'll use it to get the period. And remember that the frequency is the reciprocal of the period. So so we can go about it that way. So I'm going to go grab, I don't even know which one this is, but we'll grab it there. And what you should notice if you drag it correctly is that it like changes the color to green there, so you can tell you actually do have it lined up. And then I'm going to line this one up with the start there. If I think that is lined up, because I think it turned white. Okay, so what I am seeing, and I actually have my notebook out here, is we're looking right here. And you can see where the two timers are posted. And that looks like the period is about 15.158 milliseconds. So 15.1588 milliseconds. And then to calculate the duty cycle, we need to know the time high over the total time. So we've got the total time for one complete cycle, and we'll just go and drag this back. And there's our time high, and I'm looking down here, so that's 10.068. What are we in? Milliseconds, 10.068. And so the duty cycle for that should be, open up my calculator. So we have 10.068 divided by 15.158. and I have about 6.664, which is about 66.4%, is what I'm getting for the duty cycle for this particular circuit. Yeah. And then to find the frequency is the number of cycles per second. And so I'm just going to get that from the period. And so the frequency is 1 over the period, which is 15.158. Now remember that is in milliseconds. So you're basically multiplying by a factor of 10, like of 10 to the third in your denominator. I just am more comfortable changing that over into seconds before doing the calculation. But that is just me. Some people are totally fine with just converting it over into kilohertz when they're done. It's a personal preference thing. So 1 divided by 0.015158, which gave me, make sure I did that right, milliseconds. Yep. 65.97 hertz. So that's what I got for the frequency there, or about 66 hertz if you wanted to round up. So that would complete steps 1 and 2 of activity 1.2.5, where you're constructing the circuit, simulating it, pulling up that oscilloscope, and calculating the frequency and the duty cycle of that. And then pretty much what you guys are going to do in your teams then is you're going to swap out the resistors and the capacitors. You're going to just swap them out according to like what the table says, and then repeat that process. And the idea of the investigation is to figure out how the values of the resistors and the capacitors in the circuit affect the clock timer. And then you're going to do a giant like copy, like whoops, like so. You're just gonna copy and then paste that into your circuit with your 4-bit binary counter, and then adjust the values so that you can count on the 4-bit binary counter the way that you want. So hopefully this video helped anybody that needed to see that demo done again in addition to what was done in class.